Hello and welcome to more nerdy rodent geekery. Today I'm once again diving into the world of Stable Diffusion, but this time I'm looking at the Stable Diffusion Web UI repository. Why? Because it has absolutely loads of things in it. So there, the feature showcase, you've got the original Stable Diffusion, of course. You've also got Inpainting, Outpainting, prompt matrices, support for 4 gig video cards from the Basu Jindal repositories, all sorts of things, a whole load of stuff. There's loads of things going on in here. All right, now this repository mostly has instructions for Microsoft Windows users who don't have Stable Diffusion installed already. So if you're one of those people, if you're using Windows, you haven't got Stable Diffusion installed already, then by all means go through all that lot, follow those instructions and do it that way. It will probably work. Not really tested it on Microsoft Windows, but I assume it does. I, of course, am doing things ever so slightly differently. I'm using Ubuntu 22.04. Yes, I've actually upgraded from 20.04. As mentioned, feel free to use Microsoft Windows, but the performance and commands may vary. I have an NVIDIA GPU, the NVIDIA drivers and CUDA toolkit installed, and I am using Anaconda to manage my virtual Python environments. All these links are down in the description. So if you want to download and install Anaconda, you can do that. The same is if you want to install Ubuntu or your NVIDIA drivers. So yes, just click on those links, go to the sites, download the stuff, and you'll be in much the same place as I am. So why would you want to use this web UI? Well, normally, with a normal Stable Diffusion installation, you'll be running things with loads and loads of scripts. You'll be generating thousands and thousands of images. You'll come back in half an hour and you'll sort of trawl through them and go, yes, that one's good, and no, that one's no good. And yeah. So this is more of a way to play with just a single image at a time and then make little changes to it. So you can inpaint and you can outpaint and yeah, all that sort of stuff. Of course, it's got a Gradio web interface as well. So if you want to connect to the web interface running on your computer here, so maybe you may want to use your iPad while you're in bed and make images that way, that's absolutely fine. You can do all that as well. Now, some things to note with the documentation on the repository is that you don't actually have to do many of the things that it says. They're all just weird. So yeah, Real ESRGAN, for example, you don't have to download any of the models. That will download everything for you, not a problem. That just does it automatically. They also suggest installing this version of Python here. Install Python 3.10.6 and add Python path to your installation. You must install this exact version. Now, of course, if you do that and you've got another application on your Windows computer that needs Python, say you previously installed Python 3.7 for whatever application it is that you're using, if you do that, that will then mess up that previous application, which is why I tend to use Anaconda. Okay, alrighty. So I'm using Anaconda to manage my virtual environments. That does all the paths and keeps everything separate for you. Now, there's also a taming transformers requirement that seems to need it installed in the parent directory. So if you've got Stable Diffusion installed somewhere, if you've got it like me and it's in GitHub Stable Diffusion, you'll be absolutely fine. If you've got Stable Diffusion installed, in /Stable Diffusion, then I don't know. I haven't got that situation, but it does tell you where it's looking for taming transformers. But in mine, it's actually looking for the parent directory, which is a little bit strange. Okay, so there's loads of Microsoft Windows related stuff on there. That may make sense to you if you're a Windows user, means absolutely nothing to me. Now, the author has stated that this is going to be a GNU Affero license. They haven't actually put a license file in there, but there's the GitHub link suggesting that it will be GNU Affero. So that's the license on this. Now, I'm assuming that you have, of course, already got Stable Diffusion installed. You've just installed it the normal way. You've conda-env created the environment.yml from the Stable Diffusion repo, and you've just installed everything normally. You're using Python 3.9, the standard way of installing everything. Excellent. All right. So if you want to see how to do that, just check out the previous video and stuff. Then the weird taming transformers bit. Now, when I started the web UI, it did tell me where it was looking for taming transformers, and as mentioned in my case, it was looking in the parent directory. So it was looking in ~GitHub taming transformers. So I had to go back one and install taming transformers in the parent directory because that's where it was looking for taming transformers. So there it is. All right. I don't know why, but anyway. You may have to do that as well, but it will tell you when you run it where it's looking for it. Anyway, so back to the normal Stable Diffusion directory. There we are. So there you can git clone this one here. You can git clone all that, and that will then put everything in this directory there. So you've got your Stable Diffusion Web UI directory. Yeah, okay, great. So you've downloaded that. So then you can pip install -r Stable Diffusion Web UI requirements.txt. There we go. Copy, paste that in. And this will basically download all the extra stuff that you need in order to run this web UI. So it's, as you can see there, it's downloading Catherine Croson's K Diffusion. So that gives you all the extra samplers and things. It'll also download GFPGAN and a whole bunch of other stuff for you as well. Now they do also say that you need to update your NumPy install as well. So I did a pip install -u NumPy. That got me up to version 1.23.2. It was on 1.22 before, so not entirely sure that that's needed. But anyway, you will actually need to download the GFPGAN models. There's a selection of models. I'm using 1.3. If you've been following along with all my videos, you will of course already have GFPGAN installed, in which case you want to link wherever you've got GFPGAN installed, and the PTH file is there in experiments, pre-trained models, GFPGAN. So if we have a look in there, Stable Diffusion Web UI, there it is, there's the PTH file, GFPGAN, and it's linked to my actual GFPGAN install. If for whatever reason you haven't been following my videos and installing absolutely everything that I've been installing as well, I don't know why you wouldn't do that. That's strange. You can just download the weights there. So wget, and there's the PTH file, and that goes into your Stable Diffusion Web UI directory. Okay, so there you go. You've downloaded the repo, you've pip installed the requirements, you've got your GFPGAN weights, you're ready to go. So it's basically just 3 instructions as opposed to all of whatever that is. Yeah. All right, so let's start this Web UI up. There are a couple of options when you're using the Web UI. If you have a 4 gig VRAM card, then you want to use the ---- low VRAM option. Or if you've got a 10 gig card, then maybe you want to use the medium VRAM option. If you've got other devices on your network, let's just pop this in as an example, because why not? Then you can use ---- listen, and that will allow you to use other devices on your network. You could also use the ---- share option, and that will create a Gradio app URL, which is a public one, so then anybody can connect to that. But yeah, ---- listen will allow you to connect to your local system. It will basically launch it on localhost rather than on the Loopback device. So if you know your computer's IP address, you can just connect to that on port 7860. Then you can connect from your iPad to Stable Diffusion running on your computer and play with stuff in bed. So here we are. We've got it running on my local URL. Let's open that link. There we go. Right. So there's a few general bits and pieces here. You've got the various samplers, you've got GFPGAN, and you've got tiling. Now those are the new things here. So you've got all the samplers there, you've got GFPGAN, and then you've got tiling, and that is also available on the image to image as well. Yeah. So GFPGAN is for faces. That's going to make faces a lot higher quality. Tiling basically gives you the opportunity to tile everything. So let's just show you that. So say I do a steampunk cat in a cyberpunk city. Right, let's generate that. So this is the just the defaults. So we've got 20 steps. It's using the Euler A. As you can see, that's quick and easy. Now, if we turn on the tiling option, this is going to completely change the image, but it will allow us to do tiling. Ooh, okay. So there we've got the cyberpunk city, and then when we copy that, so we go over to our image editing program, and we'll paste that in. So we've got that there. Now, if we make this canvas a little bit bigger, say we increase the width to 1024, okay, and then if I paste that in again, then we've got this, and then assuming I can actually line stuff up properly, there we go. There you go. See, tiled, absolutely seamless. So that's the tiling option. So that way you can make really, really big images, tile them as much as you fancy, and yeah, excellent stuff. So that's tiling. That is tiling. Let's turn that off because we don't want tiling anymore. Okay, so what else have we got? We've got things now down in the scripts. So by default it's none. So then you've got XY plot. So this will create loads and loads of images, but on a single thing here. And you've got an X-axis and a Y-axis. So it's got various options in there: seed, steps, config scale, sampler. So you can play with whatever you want in there. So let's do the default seed and steps. So say you want to have a look at seed 9, 10, and 11. for example. And you want to know what that looks like with 10, 15 or 20 steps. Yeah? Now this will take just a few seconds to generate. So that will go through. So I'm going to create the 9 images there. And just make this interface a little bigger. Alrighty, there we go. So now we've got 10, 15 steps and seed 9, 10 and 11. Yeah? So there you go. There's the XY plot. So that's what that does. That's what that does. Then you've got the prompt matrix, which is very, very similar, apart from you want to separate the prompts via the pipe key. So you want a steampunk cat in a cyberpunk city, or maybe I want it in a sewer, or maybe a bar. Okay, so that'll go through and generate a grid. So it's very similar to the XY grid, but it's going to make a steampunk cat in a cyberpunk city, a cyberpunk city sewer, cyberpunk city sewer bar. Yeah, so it'll give you all the variants of the things that you've separated using the pipe key. So let's have a little look at those. So there we go. There we go. So we've got the bar, city, sewer, city sewer. Yeah, all the different variants. All the different variants there. All right. Okay. So let's just pop that back to normal, and we'll increase the sampling steps. There we go. Got 25 steps on there. It's all the usual things there: config, scale, and height and width. We'll just generate another steampunk cat in a cyberpunk city sewer. Oops. Hang on. In a cyberpunk city. Let's just regenerate that. Right, okay, so this gives us a steampunk cat. There he is. Look, doesn't he look cool? Doesn't he look cool? All right, so I'm just going to send him to image and send him to Inpaint as well, and then go over to the image to image tab. Right, so here we could redraw the whole image. We've got the sampling methods there again, and all this other stuff. So say you want to redraw the whole image. Let's do a steampunk rodent in a cyberpunk city. Now the main thing that you want to play with here is the denoising strength. So for example, if I set that up to 1, oops, let's just refresh that, generate there. So if you set the denoising strength to 1, it will, for example, completely rewrite that image. Whereas if I set the strength down to about 75, 74, then it will keep it fairly similar and not necessarily rewrite it completely. Or if I change the denoising strength all the way down, then we'll start getting some very, very limited changes indeed. Yeah, basically anything below 0.5 and it's not going to change very much at all. And 1, it's going to completely change the image. Now, when you get the image to image thing in there, this is of course exactly the right size. It's 512 by 512, but you could crop and resize or resize and fill if the image is a different size. Of course, you can play with all the different samplers as well, and GFP and tiling if you want to as well. Right, so what else have we got in here? So yes, you can also do a little bit of masking as well. So maybe you don't want to replace the entire image, you just want to inpaint part of the image. Yeah. So maybe you don't like this bit here. Maybe you don't like this bit here. So we'll change this bit. Very, very badly drawn mask, and then we can use a prompt just to tell us what that bit of masking is. All right, so I've created a mask there, and then I'm going to change this to DDIM, and I'm actually going to increase the steps a little bit there for this masking. I'm going to keep the mask blur on 4. I'm going to change that to latent noise, so that's going to just make that into noise. And I'm also going to inpaint at full resolution. What that will do is basically make that at full size and then scale it down. And I'm going to change this completely. So rather than having that, I'm going to have a mechanical piece of technology. And then, when I do the generate, it's just going to create that one little bit there. There you go. See? So it's completely changed just that part of the picture. So if you wanted to give him different eyes, for example, or let's regenerate that, and we'll get another mechanical piece of technology. Yeah, there you go. So you can change your image. You can put different things in, and you can inpaint to your heart's content. Alrighty, okay. So we've got loads and loads of other things in there. So redraw the whole image is basically like variations. You've got Loopback as well. Now, Loopback, you need to increase the batch count for that. So that'll make things... Let's change this back to the Cyberpunk cat. So that will use this image. It'll then generate a new image, and then it will use that image to generate the next image, and then that image to generate the next image. Yeah? Okay, so if we do generate, that will sort of show you what's going on here, but you have to increase the batch count for this to actually work. Again, don't forget to set your denoising strength to whatever you want it to. And there we go. All right, so now we've got the steampunk rodent in the cyberpunk city, and that gives us that first image, and then the next one is based on that one, and then the next one is based on that one, and then the next one is based on that one. Yeah, so you get the idea. You get the idea. So that'll get you a whole bunch of different images. You can of course click on the individual images, and that'll give you this little selection thing down the bottom there, and that's how you select all the different images. So that's pretty cool. That is pretty cool. Now then you've got the Stable Diffusion Upscale. Now with this one, we've got some notes in here. So when you're doing the upscaling, this is a little bit like Go Big. So you want to set the tile overlap, pick an upscaler, and use a low denoising strength. Yeah. But you can use a high denoising strength as well, just to get some really, really weird effects. So we'll show you the first one. So if we change the denoising strength down to about something under 0.2, that's fine. And I'm going to put the config scale up a little bit. And we're going to make this a cyberpunk cat in a steampunk cat in a cyberpunk city. Right. So this is going to be doing a little bit of upscaling. Yeah. And it's got the upscaler that you can pick here. So I'm going to use the real ESR again 2 times. Okay, so this will upscale that image a little bit like Go Big, as mentioned. So it uses all these tiles overlaps, basically upscales the image, cuts it into little pieces, upscales all those individual bits, and then stitches it back together again. So that's actually a 1024 by 1024 image. It's upscaled it from 512, 512. Yeah, okay. So if you, as mentioned, put the denoising strength right up to 1. So this is going to completely change the image, and it will sort of give you a better picture of what's going on with this tiling overlap. So this is going to change the entire image. But it's taking a little bit longer, as you can see. I'm using DDIM 40 steps. Generally speaking, DDIM's pretty good at doing inpainting and stuff, but yeah. This'll it may surprise you what it's going to look like. So we're waiting for our steampunk cat in a cyberpunk city, upscaled version with denoising strength 1, and there you go. So it sort of puts all the bits and pieces. So you can see there where it's been joining all the bits and pieces together. So it looks at that little bit of the image and upscales. It looks at that little bit of the image and upscales. It looks at that little bit of yeah. So it may be that you want to actually create that sort of image, so you can play with the tile overlap as well and get a different sort of effect. So denoising strength 1 won't upscale it, but it will still have an interesting effect. So that's quite a fun thing to play with. Now down in the scripts here, you've got poor man's outpainting as well. So if we scroll right down, we've got scripts, XY plot, prompt matrix, exactly the same as before. But we've got poor man's outpainting. Now this gives us a few more options. So we've got pixels to expand. So how big is it going to make it? I'm going to make that 64, make it ever so slightly bigger. Masked content, fill, original, latent noise. So exactly the same as before. I'm going to make it latent noise. And the outpainting directions as well. It's got left, right, up and down. So that's basically going to expand it in every direction with all of those ticked by default. So steampunk cat, cyberpunk city, outpainting version. And I'm going to pop that back actually to redraw the whole image. Yeah, okay, so let's have a look at a little bit of outpainting. This will take just a few seconds as well. So that's basically going to make that cat a little bit smaller and then fill in the image around it. So it's kind of useful. Maybe you get a cut off face, yeah, and you want to fill in the rest of the face. That's sort of what it's used for. So there you go. It's sort of made that little bit smaller by 64 pixels and filled in the rest of the city around it. So there you go. Poor man's outpainting. As mentioned there, you want to have the denoising strength quite high and set the config scale above 8. You want to increase the step count as well, even with Euler A. and set pixels to expand and the marks blur down there. So set those little bits however you want it to go. Yeah. All right. Okay. Now it does also support textual inversion. Not going to go through that on this video because it's already way too long. But basically, create an embeddings directory in your stable diffusion directory. Put your PT file in there, and then when you use the words for the thing that you have done your text inversion for, that will use textual inversion. Now, of course, there's a load of other extras in there, so you can just do the upscaling if you want to do upscaling, but that's available in the other bits and pieces as well. You can drag and drop pings in there, and settings. You may want to play with a whole bunch of things in there too. For the most part, you just want to change the font. So there you go, quite a long video, but there's absolutely loads of things for you to play with in there. It does get updated quite frequently too, but that is Rodent out for now.